शुक्लां ब्रह्मा विचारसार परमा आज्ञा जगद्व्यापिनी वीणा पुस्तकधारिणीम् अभयदां जाड्यान्धकारपहां हस्ते सात्विकमालिका विदधति पद्मासने संस्थितां वन्दे तं परमेश्वरी भगवती बुद्धिप्रदां शारदाम्.
Mangsir 15, right? Mangsir 15, 2076. So we are in precious National Academy that is located in Mirki, Kathmandu. So we are in class 9 and the students of class 9 are going to present themselves in a topic life. Actually we have started this system, so let's see. And who are today's presentators?
Sabbu and Nisha.
Are you ready to welcome them?
Yes, sir.
Sabbu and Nisha will come tonight.
I am standing in front of you to teach the lesson light. Before we begin our class, I would like to give short introduction about this class. Today we are teaching you about the chapter light and some terms related to light, and after that we will give some examples of refraction of light, and then we will do some practical. For that we need queen, chopstick, glass and some water. Now I would like to begin our class. Sabbu will help me.
The time now is
And she will do
6.
some practical.
50.
Light. There are different types of energy. Among them, light is one of them. Light is a form of energy. It is a type of energy which gives the sensation of vision to our eyes. The speed of the light is 3 into 10 to the power 8 meter per second. The fastest moving object in this whole universe is the speed of the light. After giving the introduction about light, I will teach some other things related to light. The speed of the light is always constant. In our junior class, we have read that light always travels in a straight. Light never gets bent, but that is totally wrong. Lights get bent when it goes from one to another medium. That is, from denser to rare medium, or from rare to denser medium. The path through which the light travels is known as upturned medium. There are two types of medium, and they are denser and rare medium. First of all, denser medium. What is meant by denser medium? The medium where the speed of the light is less, and that is called the denser medium. And the medium where the speed of the light is more and density is less, that is called rare medium. Did you get idea about rare and denser medium?
Yes.
Then I would like to ask a question to Miss Kalpana Palajiji. What do you understand by rare and denser medium?
The medium in which the speed of light is less is called denser medium. The medium in which the speed of light is more is known as rare medium.
Thank you. Okay, now I'll tell. I have already told that lights get bent when it travels from one to another medium. For example, this is glass. This is glass. When the light comes from this source and enters this glass, and this is normal, then it gets bent. This process of bending of the light is called refraction of light. Refraction of light. Now do you understand what is meant by refraction of light?
Yes, Nisha.
There are some laws about the refraction of light. There are many two laws of refraction of light, and I will write both of them. Laws of refraction of light. Law number 1. The ratio of the sine of the angle of the incident to the ratio of the sine of the angle of the refraction is constant for a given pair of medium or media. This constant is known as Snell's law. It is called Snell's law because it was discovered by a scientist named Snell. Or it is also known as refractive index. Ratio of the sine of the I to the sine R is constant for a given pair of medium, and that is called refractive index. Or it is also known as Snell's law. I would like to ask a question for Rajna. Okay, tell me, state the first law of refraction of light.
The first law of refraction of light states that the sine of angle of incidence is constant with sine of angle of refraction.
And that is called
Snell's law.
or
Yeah.
refractive index. Yes, you may sit down. Now I will tell the second law. The second law of refraction of light states that the incident ray, the normal and the refractive ray all lies on the same plane at the point of the incident. Did you get it? Yes, Law number 1. Again I will tell. The incident ray, the normal, refractive ray, all lies on the same plane at the incident. If this is glass slip, okay. If this is glass slip, and a light comes from this source, and here is normal, and that is refractive ray, and this all lies on the same plane. That is the incident ray, normal, and the refractive ray all lies on the same plane. Now second law states that the ratio of the sine of the angle of the incidence is equal to the the ratio of the sine of the incident is equal to the ratio of the sine of the reflection, and that is constant for a given pair of medium, and that is called Snell's law or refractive index. Now did you get? And now I'll have to use some examples of refraction of light, and Sabbu will do some practical.
Faster than my pencil. And one going. Faster pencil in water in glass. Yes, no, I going. See how it does not.
She is telling that for testing the refraction of light, first take a glass, some water, and a substick. I would like to call one student and tell or let him or her see what is in this glass. Please answer, come here. She will tell what she has shown in this class. Okay, please, one of the students come. Please turn this side. No one wants to come, then I'll tell myself. Then I'll show to you all, one by one. What can you see? Yes, sir. Okay. Yes, you. You. Yes, you. What have you seen? The substick is straight up bent. Then these sticks get bent. Like this we have seen, yes? These substicks get bent, and this is because of refraction of light. Now I'll give second example, and I'll show to you all. Can you see coin? Wait. 2 coins, yes? Okay. In this example 2, for example, this is glass, and water, some water, and this is coin. But when we have seen this coin from here, this is the then the coin is seen here. This is also
The time now is 7 o'clock.
Another example. This is Earth, and this is a person or is an observer, and this is Earth. And there are some atmosphere which contains different types of gases: O2, CO2, nitrogen, etc. And Sabbu is showing the stars. And these are stars. Have you ever noticed in the night sky? We have seen some stars, and they look like twinkling. Yes? But this is also because of refraction of light. Like star seems like twinkling, it is also because of refraction of light. It is because, for example, this is an observer. And when this observer sees these stars, then the stars coming from the source has to pass through the different atmosphere which contains different types of gases of different densities. The gases found in the atmosphere of the earth has different densities. Some has more, some has less. Then the speed of the stars will also change, and then when it comes to the observer, it seems like if it is twinkling. This is also because of refraction of light. I have given 3 examples of refraction of light, and that is this: the star seems twinkling, and then the sticks get bent, and the coin seems to rise up. These are all the examples of refraction of light, and there are other examples of refraction also. Now I am giving the example of the dispersion of light. Dispersion of light. There was a great scientist named Sir Isaac Newton, and he discovered that a light has 7 different colors when it travels from a prism. This light has, for example, this is light. Light has only one color, and that is white. When it passes from a prism, for example, this is prism, then these white lights get split out into different 7 colors. For example, red, indigo, green, yellow, orange, etc. The process is known as dispersion of light. These 7 different colors of rainbow can be memorized by a formula. This is the formula to remember all the colors of the rainbows. B stands for violet, indigo, blue, green, yellow, orange, and red. Now I'll teach you about how the rainbows are formed into the atmosphere. After a rainfall, some droplets are formed in the atmosphere. And these droplets of the rain acts as a prism. These all are the prism. These all are prisms. And these are water droplets. When the light passes from those water droplets, which acts as a prism, the white light splits off into 7 different colors, like I have told already. Like this, the rainbows are formed into the atmosphere. And this is a diagram about how rainbows are formed into the atmosphere. In our junior classes or in class 8, we have read about the reflection of light. Amsa, please stand up and tell me what is reflection of light?
When light passes from one medium, reflection of light or reflection.
Reflection of light.
Bending of reflection.
Yes, reflection. Yes, reflection of light. It is not in our book. We have read this in junior classes, in class 8.
Passing of light from one medium to another.
If that is a good try, we can start. I will tell the answer of reflection of light. In our junior classes or in class 8, we have read the process of returning of the light to the same medium after reflection is known as the reflection of light. That is, when the light passes through a medium and if it returns to the same medium after reflection, then that process is known as reflection of light. It has also some laws. Law number 1. The normal angle of incident, that is I, and angle of reflection all lies on the same plane. This all lies on the same plane. Law 2 states that the angle of incident is equal to the angle of reflection. That is law number 2. Now did you get some ideas about reflection of light?
Yes.
Now I'll tell you about the refractive index. In law number 2 of refraction of light, we have read about this refractive index. This constant is known as refractive index. There are some formulas to calculate the refractive index. One of the formula is this is one formula, and second one is velocity of the light in air, the velocity of the light in medium. These are the two formulas to calculate the refractive index.
The time now is
Now did you get ideas about
7,
refractive
10.
index?
Yes, Nisha.
You stand up and tell me what is the refractive index.
It is the refracting index basically consists of the formula 1 sin I by sin R, and it is Snell's law. This cycle.
Okay, I think that is correct. Yes, we have told about these formulas and we have given a definition of the refractive index. I think that is correct, or I think that is correct. We have to understand it clearly. That is where this definition of refractive index is very easy. You need to remember the second law of refraction of light. And this second law of refraction of light states that sin I to the sin R is constant, and that is called refractive index. This definition is very much easy, and this is the formula also. And then I will teach some others about the light also. Light. What type of wave can light be? No. We have read that there are two types of wave. Transverse wave and transverse and longitudinal wave. And we have read that in the chapter sound also we have read about this transverse and longitudinal wave. A transverse wave. The definition of transverse wave states that it is a type of wave where that this transverse wave do not need any material medium. That means it can travel through the vacuum also. And we have read that light also do not need any material medium to travel, so it can travel through the space. Now light is also transverse wave, or it can be also told that it is an electromagnetic wave, because electromagnetic wave also do not require any material medium for its propagation. Before we teach other class, some questions should be asked. So Aditi, please stand up, and Aditi, please stand up. What are the types of wave?
Longitudinal wave and transverse wave.
And please tell the definition of those waves.
Those waves which don't need material medium for propagation of light is known as transfer wave, and those waves which needs material medium for the propagation of light is called longitudinal wave.
Okay, listen. Actually, we can classify the waves into two types. He said, what are they? Longitudinal and transverse. That is one. So your question was, you asked her what is longitudinal wave and what is transverse wave. Basically, we have to know. She gave the example of electromagnetic wave and mechanical wave. Those waves which need material medium for propagation, that is mechanical wave. The wave which does not need any medium for propagation is called electromagnetic wave. But transverse wave and longitudinal waves are a bit different, isn't it? So transverse wave is electromagnetic wave because it does not need medium, but definition is a bit different. Suppose if we draw this one, this is the diagram of transverse wave. What is this? Transverse wave. Next one is suppose here, rarefaction, and what is here? Compression. R here, C. Again, rarefaction and compression. Again, rarefaction, here, compression. Rarefaction, what is spelling? RAREFACTION. And compression, COMPRESSION. And here, uppermost point is stress, lowermost point is drop. So, what is transverse wave? The wave, here we have to know, the wave in which the particles of the medium vibrate perpendicular, up and down. The particles of the medium vibrate perpendicular to the direction of propagation of wave. Wave is going like this, isn't it? But the particles are moving up and down, perpendicular to the medium. That is transverse wave. Example of transverse wave is light wave. Isn't it? Light wave is transverse wave. Next one. The wave in which the particles of the medium vibrate to and fro, means forward, backward, forward, backward. That is which wave? Longitudinal wave. Example is sound wave. Okay, so you must not mix up. Alright, Sangeeta, first. To pause is not pausing. Down, red way.
Now guys, we have practical to prove that a white color consists of 7 different colors. To prove that white color consists of 7 different colors. For that, for this experiment we need a Newton disc, and here are 7 different colors, and here is wires, and when it is connected to electric source, then the Newton disc will go on rounding, and this, when it goes round, after it is connected to a source of electricity, and then we can see that all these 7 colors is seen as a single color, and that is white color. First of all, there are 7 different colors in this Newton disc. This is a Newton disc, and when this wire is connected to a source of electricity, then this Newton disc will go down, and after that, these 7 different colors will be seen as a single color, and that is white color. This experiment.
The time now is 7:20.
Different colors. Light is sun. We get the light from sun. And in simple language, light is also a form of energy. Without the light, we cannot see anything. Light is very much necessary for us to see the surroundings. And if there is no sun, then we cannot see anything because there is absence of light. this life chapter has come to the end. I hope you like it.